12.5 is a learning target that takes every single learning target we've done in this unit and combines it into one big lesson. The trickiest part of this unit is being able to recognize when you can factor and what method you want to use, right? Am I just taking a GCF out and stopping? Am I using the multiply to the number, add to the middle number? Do I have to multiply the last and the first number? How do I know when to stop? Is it a difference of perfect squares? So that right there, and that's kind of what I just summed up in this little sentence right here, that's the hardest part of this unit. So in this learning target, we're going to see a mix of all the problems we've been working on, and your goal is to try and figure out how you start and when you stop. So I've kind of put together this little tree right here. So your first step always is look for that GCF. Before you start doing the X, before you start drawing your parentheses, you always need to find a GCF. Sometimes they'll have them, sometimes they won't, but you have to look for one first. Okay? Then you're going to look for how many terms your problem has. If it has 3 terms, you're probably going to get a trinomial. Okay, and there are 2 types of trinomials. There's a trinomial that doesn't have anything in front. It's got like the 1 in front. And then there's the trinomials that have a number in front, that a. So remember, we treat those a little bit differently, right? If it's just a trinomial that has the 1 in front, we just have to find factors of the last number that add up to the middle number, right? We do our x for both of these, and we do our Punnett square, and then we find out what's on the outside, right? For the other type, where you have a number in front, you have to do the a times c. So you have to find factors of ac, that's basically the first times the last number, that add up to b. Okay? And you're still going to use the Punnett squares, right? You're always going to use the Punnett squares for both of these. Also keep in mind that you can only use the Punnett squares if you have an x squared, an x, and then a number. If you have anything other than this combination, you cannot factor using the x method in the Punnett square. It just doesn't work. Okay? The other option we have is if your problem only has 2 terms, right? After you find the GCF, you suddenly have something that looks like this, something minus something. It might not look like this, you might have something plus something, and we'll talk about that when we get there. But for the most part, you might see something like this, and it might be a difference of perfect squares, okay? And it also might be someplace we stop and not be a difference of perfect squares. But remember, we have to recognize those special numbers, right? 1, 4, 16, oh, there's a 9 in there. 1, 4, 9, 16, 25, 36, 49, etc., right? And when we do that, we have to remember how we solve that type of problem, and we're going to review that going forward. So this is kind of a reference for you to know what steps to take when. So if I were you, I might tear this page off on your notes when you start to practice and use this kind of as a guide. So I'm going to show you 6 different problems, okay, that are kind of behave a little bit differently. So here's problem number 1, 4b squared plus 24b plus 20. The first step is to check for a GCF. So I'm going to look at the 4, look at the 24, and look at the 20, and ask myself if they have anything in common. I know they have something in common because they are all even. Okay, so it could be a 2, but I also know that it's a 4 because 4 goes into 24 and 20. Okay, so I'm going to pull that 4 out, and you need to write this step in. Some of you are forgetting to write in what's left over. That needs to happen. I need to see that on your work. Okay, so what I just wrote right now, I need to see. I know my 6's look like B's, and I'm sorry. I don't know how to fix that. Now that I have this trinomial, do you see how this is a trinomial, and it's got the b squared, right? It's got a b, and it's got this number here. That tells me that I can now take that trinomial right here and use the Punnett square and the x. So I'm going to take that last number 5 and the middle number 6, and I'm going to try and see if I can find the pattern. Okay? You're going to figure out soon that it's 1 times 5. 5 times 1 is 5. 5 plus 1 is 6. So I'm going to take my Punnett square, And be very careful here. Don't put in this top one. You're going to put in the one I've underlined. So you're going to put the b squared here and the 5 here, and then the 5 and the 1, 5b and 1b go here and here. Now work your way out. B and b go here, a 5 goes here, and a 1 goes here. Now be very careful. For your final answer, you have to pull this 4 down. That has to be part of your answer here. If you don't put that 4 in, then your final answer is not correct. That 4 is part of the problem. Okay, so then put in your binomials, b plus 5, b plus 1. Put a box around your final answer. For this unit, that's really important because there's a lot of work here, and I need to know what your final answer is. It's really hard for me to do that without a box. All right. The second problem, 2x squared minus 25x plus 63. That first step is to look for a GCF. So 2, 25, and 63. 2 is the biggest one it can be because this guy only has a 2. And I know 2 doesn't go into 25, so right away there I know there is no GCF in this problem. That's okay, that's going to happen sometimes. Now I notice that 2 is in front, so this is the type of problem where I'm going to have to do a times c. So I'm going to go ahead and figure out what a times c is. I know that 2 times 63 is 126. Now 126 is a big number, and we've talked about ways to figure this out. And my way is I always start by writing down 1 times, 2 times, 3, 4, 5, 6, 7, etc. Then I take my calculator, and I'm going to go ahead and type in, I know that 1 times 126 is good. And now I'm going to do 126 divided by 2. I get 63, so 2 times 63. 126 divided by 3 gives me 42. You might want to draw your x here first, just to like kind of give yourself a, so I'm going to put a 63 up here and a negative 25 here. Okay. All right, let's keep, and I as I go through these, I kind of check in my head whether these will give me a 25, a negative 25, right? I also know that since 25 is negative, I can put a negative here and here. Because I know a negative times a negative is a positive, but I also know this bottom number is a negative, so like they have to both be negative. So I'm going to keep going. 126 divided by 4 gives me 31.5. So I know that that doesn't work. I'm going to cross it out. 126 divided by 5, that I know that won't work. Gives me a decimal, so that 5 isn't 1. How about 6? That gives me a 21. Okay, and I kind of can maybe see 21 and 6 giving me a 25, but when I really think about it, that would give me a 27. So I'm getting close. Let's try 126 divided by 7, and I get 18. All right, and there's my answer. 7 and 18, negative 7 and negative 18 give me negative 25. Now I'm going to go draw my Punnett square. That's my next step. And I'm going to put the 2x squared here, and the 63 here, and then these two numbers I got, the negative 18 and the negative 7, go here and go here. They could be in either place, it doesn't really matter, like we've talked about. Now I'm going to go ahead and find my GCF to start solving this puzzle. So I'm going to use the highlighter, and I want to find the GCF of this, and I want to find the GCF of that. So I'm going to start with this one. 2x and 7x only have an x in common. 2 and 18 have a 2 in common. Now I'm going to work backwards. I know this has to be negative 9, because that's 9 times 2 is negative 18. And I know this has to be negative 7. Okay. Now I'm going to write my final answer. I don't have a GCF, so nothing goes in front, and I get 2x minus 7 as my final answer. Put a box around it. Okay. Next problem. I've got an x cubed plus 9x squared minus 52x. Again, I'm always going to check for a GCF between the three numbers, or 4, however many you have. I notice that none of the numbers they have in common, but they all have an x in them. So I've got to take that x out. I'm left with x squared plus 9x minus 52. Now I notice that this is a trinomial, and it fits my pattern of x squared, x, and a number. So I can go ahead and put this in my x, negative 52 and 9, and now I can try and find these numbers that work. I'm going to write my factors of 52, 1 times 52, that doesn't work. 2 times 26, that doesn't work. 3 doesn't have one. 4 times 13, and I notice this has to work, right? I've got a negative 52, so I'm going to make the 13 positive and the 4 negative. That will give me a positive 9. I'm going to go into my Punnett square. I'm going to put an x squared here and a negative 52 here. I have a negative 4x and a 13x. This is x minus 4, and this is x plus 13. So my final answer, bring that x down, and then x minus 4, x plus 13. The next problem only has 2 terms, but that's not a big deal. We can work with that. Again, first find your GCF. GCF between 9b squared and 3v, well, they each have a 3 in common, but they each also have a v in common, so I can pull out that. I'm left with 3v minus 1. I know a lot of you struggle with this 1 thing, but if you're pulling out the entire thing, you're going to be left with that 1. Alright, don't put this, 3v times 3v. That doesn't make any sense. That's just 9v squared, and what happened to the negative 3v? And I've seen that happen a lot with you guys, so just be careful. Now I'm going to look to see, remember that next step, and we'll go back to the beginning? If you have a binomial, you have to check if it's a difference of squares. So that's what I'm going to look for. So when I go back here, this is what I'm going to check for as a difference of perfect squares. Is 3 a perfect square? No. 1 is a perfect square, but they both have to be perfect squares. So this is as far as I can go. I'm done with this problem. I cannot continue. However, in this next problem, I'm going to look for my GCF between 18 and 2, which is 2. I'm going to pull that out. I also both see they have an n, so I'm going to pull an n out. What I'm left with is 9m squared minus n squared. Now I have to check and see if this is a difference of perfect squares. So I'm going to look at the 9m squared, and that absolutely is a perfect square. 9 and any letter squared is a perfect square, and also n squared is a perfect square like I just said. So when I go to do this problem, I'm going to bring down that 2n, and then I'm going to remember my rule about perfect squares. I'm going to put a 3 here and a 3 here, because that's the square root of 9, m here and m here, because that splits, and n here and n here, and then I'm going to put a plus in one and a minus in the other. So we really have to be able to recognize those perfect squares, because if you guys just put that thing, it would not be finished, and I would count it wrong. Okay? That's why the directions say factor completely. This is factored, you're right. This is factored, we can multiply this out and still get the first problem, but it's not completely factored. We want to make sure that it's as factored as much as possible. Okay? The last problem in this section, 8x squared minus 20x minus 252. There is a GCF here, always have to check. 8x squared, 20x, and 252. I know 252 is a big number, but you guys can use your calculators. If I go to my calculator, now I can't do 3 numbers, right? But if I go here and click on math and scroll over and then scroll down to 9, like I've taught you guys, and hit enter, get that GCD, I can't put all 3 in, but I'm going to put in the 2 biggest numbers. I'm going to put in 252, comma 20, and I get a 4. Which means now I'm looking between 4 and 8, because 8's the number I didn't use. Well, what's the GCF between 8 and 4? It's 4. So that's one way you can get around that calculator thing of not being able to use more than 2 numbers. So I'm pulling out the 4, and I'm left with 2x squared minus 5x, and I'm going to go ahead and put 252 divided by 4 in my calculator, because that's a really big number, and I can't do that mental math in my head. That's what calculators are for. And I get a minus 63. Okay? Now I'm going to look at this trinomial. Okay? Is it an x squared, x, and a number? Yep. So I can go ahead and try to use a Punnett square. The other issue is that I've got this 2 in front. Because of that, when I find the Punnett square, I have to multiply these numbers. Now 2 times 63 is 126, be negative 126. Now we've already listed off this list of numbers, right? We're looking for 126 and negative 5. So I'm not going to do that twice. I'm going to go back to the other example I showed you, and I'm going to go ahead and look at this table that I made. I don't want to do work twice. I want to do work I want to do the least amount of work. So I'm going to look at here and see if I can make a 5. I can't make a 5 out of 1 and 26. I can't make a 5 out of 2 and 63. I can't make a 5 out of 3 and 42. I can't make a, excuse me, I can't make a negative 5 out of 6 and 21, and I can't make a negative 5 out of 7 and 18. So I'm going to go ahead and go back to my calculator. And I'm going to see if there are more factors of 126 that I haven't written down yet. So I'm going to go, the next one I'm going to try is 8. So 126 divided by 8 gives me a decimal, so that doesn't work. 126 divided by 9 gives me 14. And when I write down 9 and 14, there I can see that I can get a 5 if I subtract 9 from 14. So 9 and 14 work, so I'm going to go back to my problem right here, and so that I know that this has to be a negative 14 and this has to be a positive 9. So I'm going to do my Punnett square. I'm going to put the 8x squared, oh, not 8x, see, I can easily make that mistake. I want to put this thing in my Punnett square, and it's really easy to screw that up. So I want to take the 2x squared and put it here, and I want to take the negative 63 and put it here. These numbers, 9 and negative 14, go here, and now we just pull out our GCFs like we've always done. So I know the GCF here is 2x, I know this GCF is x, I know this has to be 9, because 9 times x is 9x, and this has to be negative 7. So my final answer, I pull down my 4, I'm going to put 2x plus 9 here, and x minus 7 here. Okay? The last thing we have to do in this learning target is talk about polynomials and quadratics that can't be factored, that look like they can be, but they can't. So when I look at this first one, b squared minus 2b plus 18, it looks like something I can do the x method with. So I'm going to go ahead and try that. I'm going to put an 18, and I'm going to put a negative 2 here. I'm going to write my factors of 18, 1 and 18, 2 and 9, 3 and 6. And when I look at each of these pairs of numbers, I notice that none of them will give me a negative 2. Like, these are all the factors of them. I can't do anything with that. So this can't be factored, so I'm going to write the word prime here. Okay, it can't be factored any further. For this second one, I notice they do have a GCF. I always check for that first. So this can be factored a little bit. I'm going to take out this x cubed. I'm left with, oh, I don't know why my pen just changed color. That was weird. Okay. I'm left with 2x squared minus 6x plus 1. So when I see this trinomial, I think, okay, I might be able to factor this further. So I'm going to go ahead and use my x. 2 times 1 is 2, and then I've got this negative 6 down here. Just by looking at this, I can kind of tell that I'm not going to find a match. There's only one option to get factors of 2, and that's 1 times 2, and there's no way that this is going to give me a negative 6. Like, nope, that's not going to work. So this is as far as I can go. It's not exactly prime because I did factor something out, but that's as far as I can go. I cannot continue further. The next problem looks like I can factor it as well. It looks like I've got to multiply this 5 times 24 first. So I'm going to go ahead and do that. I get 120 here and negative 8 here. I've got to then write out all the factors of 120, and I mean all of them. Because if you don't write all of them out, you might miss one that gives you a negative 8. So your calculator can do this pretty well. You just keep dividing 120 by all of the integers. So 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and 10 times 12. Okay, now I did that really fast, but I had them written down, but you could do this in your calculator really easy. And as I'm looking at each of these pairs, 10 and 12 don't give me 8. 8 and 15 are close. That would give me like a 12, but that won't help me. 6 and 20, nope. 5, 24, nope. None of these will give me a negative 8. So this is also prime. So you can see how something might look like it can be factored, but it can't. Not every single trinomial can work really nicely. The last one that I'm looking at, and I'm always going to look for a GCF first, 5a and 18b have nothing in common at all, which is kind of okay because also difference of perfect squares doesn't have anything in common necessarily, but 5 is not a perfect square and 18 is not a perfect square. So there's nothing I can do here. So this is also prime. Okay, so this is kind of a culmination of all of the learning targets we've done so far. So I've got 6 you try problems. I'd like you to try them all on your own, and I imagine I'll be in the room while you do this because we don't do these at home, even though I've tried to get you guys to do it. So I want you to try these problems on your own. Pause the video. When you unpause, I'm just going to give you the answers, not the work. So if I see this, you don't have work, you know what happens. So go ahead and pause and try these 6 problems. Alright, here are your solutions. Please check your answers. They need to look exactly like this, meaning I've got to have a 2 in front here. This has to be the highest GCF. Some of you might have put 2, some of you might have put 3 here, but it is a 6 as the highest. So just be really careful with those types of things. Okay? There are a lot of practice problems here because this is such an important skill going into Algebra 2 when you're a junior. Okay? Good luck.